Okay, today we are talking about adding and subtracting radical expressions, and then we're also going to talk about multiplying. So kind of like the same order we did for polynomials. These are pretty much the same thing as adding polynomials. You're looking for like terms, so you always want to check and simplify before you add any like terms, because sometimes some might simplify to be the same. So you're going to circle any radicands that are the same. And that means that the number inside, so the radicand part and the index have to be the same if they're like terms for radicals. So like radical 2 and radical 2, no matter what number is on there, these are going to be like terms because of those radicals. But if I had maybe a fourth root 2, that is not a like term because that index right there is different. So if we look at a practice problem here, this first one, none of these can simplify, so you don't need to do this step if none of them simplify. Now we need to check and see which ones are like terms. So go ahead and circle any that you think are like terms. So you should get 3 radical 6 and negative 2 radical 6. That radical 5 isn't because there's a different number in there. So when you add them, you want to add their coefficients. So the radical 6 part doesn't change, but you have 3 and negative 2, which makes positive 1. You don't need to put the 1 in front, but make sure you have the correct sign. Okay, when you are writing the new expression or the final answer, I like to see it written in number order for the radicands. So we have radical 5 and radical 6 right here and right here. Those are our two final answers. And the radical 5 is a smaller number in the radicand, so we're going to put that one first. And you won't get marked wrong on quizzes if you put it the other way, but when I'm grading the quizzes online, if you want that immediate correct answer, as if you put it in number order like this, then it'll get that positive answer. Otherwise, I'll have to wait to go in and see what your quizzes look like individually. So that's it for adding and subtracting radical expressions. So let's try a little bit harder problem where we do have to simplify. So go ahead and simplify that 24. The radical 3 doesn't. And then also simplify the radical 54 with those prime factor trees. And write your new answer on this line right here. Just the simplified forms. Okay, the 3 radical 3 does not change. When we simplify radical 24, we are going to get, 2 radical, and then 6. And then with the radical 54, we're going to get, that's 9 times 6. So we're going to get 3 radical 6 here. And now we need to look for those like terms. So we have this negative 2 radical 6 and negative 3 radical 6. And I kept the signs. Big thing. Signs are important. Never forget those. So go ahead and try adding those together. Remember, the radical doesn't change. What number is going to be in front? Got a negative 5. And then notice we still have this guy right here that we haven't used yet. And between radical 3 and radical 6, 3 is the smaller number, so we're going to put that first. And then the negative 5 radical 6. Okay. The last problem here, again, they're big numbers. So when you simplify these, you're going to get, 135 is made up of 5 times 27, and then 3 times 9, and 3 times 3. So I'm going to work this one all the way through so you can see each step in case you haven't been getting those. So 24 is 12 times 2, and 6 times 2 makes 12, 2 times 3. And these are all indexes of 3, so we're looking for groups of 3. So here we're going to get negative 6 cube root, and we still have that 5 left. The negative 3 cube root 5 didn't change. And then this one, if you notice, we have 3 2's. So we're going to get negative 4 cube root, and then this 3 is left. Okay, when you simplify, this guy right here and this guy right here both have that radical 5. You might have the third one also have that radical 5, but this one doesn't. So we have the radical 5 that doesn't change, and we get negative 9. And then I have this guy left, and 3 is smaller, so we're going to put that in front. So that's what a worked problem would look like. Okay, that's it for 2.2. Moving on to 2.3. Oops. So in 2.3, we're multiplying. And it's very close to multiplying polynomials. So when you have like a 2x times a 3x, you get 6x squared. Because we multiply the variables and we multiply the coefficients differently. So that's the same thing that happens with radicals. So we do need to distribute if we have more than one term. And then you're going to be multiplying the coefficients together and then the radicands together. So you're not going to mix coefficients and radicands in the same part. And then you always need to check for simplifying and adding any like terms. So that'll be happening every time. So if you look at this first example, these right here are our coefficients. And if you notice, this is one term and then this is another term. So it's just one term to the other. So the coefficients go in front. Under the radicand, we keep the 12 and the 6, and we multiply those. We're going to get negative 10 and 72 in the radicand. And then you're going to want to simplify this. So do your whole prime factor tree thing, and then you're going to end up getting a 6 outside of the radical. So the coefficient part will get a 6. And you multiply those and get negative 60. And left over, that radicand gets a 2. And that is your final answer. So this next one, it looks like a longer example, but a lot of this, once you actually show your work on your paper, a lot of this is in your head. So this whole part right here, you don't have to show as you're working through it, but you do need to show the multiplied individual terms. So the first one we're going to do, we have 2 terms in this first parentheses, so we're going to do this one with this guy, and we're going to write those right here. So we're going to take the coefficients. So we have negative 2. This radical 5 right here doesn't have a coefficient, so we're going to put a 1. And then the radicand still stays inside. So just treat it as if there's nothing else in the problem. And we simplify that and get negative 2 radical 25. This is the part that I do want to see worked out. And then if you can simplify it at all. So square root of 25 is 5. So we get negative 10 here. So that's our first piece of the answer. We're going to do the same thing going from this negative 2 radical 5 over to the radical 4. And that is going to go right here. Oh, I put some typos there. So we're going to take the negative 2, and again, there's no coefficient. But now we have radical 5 and radical 4 that both stand to the radicand. Okay, we multiply those. We get negative 2 radical 20, and that does simplify to negative 4 radical 5. So that's the second piece of our answer. We're going to do the same thing, but now we're going to look at that radical 3 and whatever sign is with it. And it's going to go first to this radical 5. And there are no coefficients on this, so these are both just 1 and 1. But the radicand part is 3 and 5. So we get 1 radical 15. So this step is definitely a key part. If you can't figure out the coefficients are separate than the radicands, that's going to be a hiccup. And then this one does not simplify, so we're going to stop right here. And we don't need the 1 in front if it doesn't have a negative. So that's the third part of our answer. And the last one, let's do a different color here. We have this same radical 3 with the radical 4. That's all it's left. And, oops, I've been forgetting to color these. So on that last one, we're going to have, again, neither of these have coefficients. But under the radical sign, we're going to have a 3 and now a 4. So we get 1 radical 12, which does simplify. So when you break 12 down, you get a pair of 2's. So we get 2 radical 3. And that's the fourth part of our answer. And when we write it, we do want to write it in order. So we're going to start with that negative 10 because it doesn't have a radical. And then we're going to go to the 2 radical 3 because that's the next biggest radicand. And then negative 4 radical 5. And you don't need the plus sign here if you have the negative. And then we get radical 15. And we do need to check if there are any like terms. But here we have a radical 3, 5, and 15, so those are not the same. So we stop with this answer. And box your final answer. Okay, the last problem, I'm going to show you what it looks like without having all of the in-between steps. So if you take a look here, we've got 1 term in front and 2 terms inside. So make sure that you only do once and twice. You don't want to multiply the 5 and the radical 6 as 2 separate terms. This is all 1 term. So we multiply these. The first one, radical 3 times radical 5, we get radical 15. And then the second one, there's no coefficient. So we have negative 5 radical 18. 3 times 6. Then this guy does break down. So our final answer, we have radical 15 take away 15 radical, 2. And check the order. We're going to reorder this just because on a quiz, if it's ordered correctly, you won't have that marked wrong the first time you try it. So when I do quizzes, if you write it as this way, when I go look through your papers, you'll get a 4, but when you very first submit it on the computer, you'll get a 0. So that's why if you write it the correct way, you don't have to worry about did I do it right or not. And that is it. Please make sure that you do all of the odds for your homework assignment, and when you finish, there is a coloring activity on the front podium by the calculators.